Hello, and welcome to Applesauce Plus in your retro toolkit. I'm going to talk today about the new Applesauce Plus. It's a disk imaging hardware. Tell you what it is, how it works, and hopefully clear up some possible misconceptions people have about it. The earlier version, a lot of people think because it was originally designed to work with Apple II disk drives that's all it does, but it does much more than that. So let me introduce myself. My name's David Williams. I spent most of my career as a software developer. I learned to program on HP 2000 Level F timeshare basic systems. My first job was working on Honeywell 6660 mainframes. I've done everything from general business consulting. I've done some game development. Worked in the public safety market, oil and gas industry, which if you live in Houston, you're going to probably end up at some point or another. My favorite project that I worked on was down in the Texas Medical Center writing DNA sequencing software for the Human Genome Project in the early 90s. I really enjoyed that one. I'm also a computer collector, as a lot of us are. I bought my first computer, an Apple II Plus, in 1980. Shortly followed, not too long after that, by an Atari 800. And then when I decided I needed to kind of be able to handle the PC world as well, I bought an AT&T 6300. At which point my collection kind of reached critical mass, I guess, because it just started sucking in more and more systems. I'm sure you're familiar with that.
No.
And yes, my 3 systems, I still do have all of them, and they do still work. So since then, I've retired, and I consider myself kind of an unofficial archivist. I spend my time most days now trying to image software, preserve it, image documentation, preserve it, restore. I tend to go to more unique and obscure systems. I've got a table right outside the door here where I'm showing off an MTU 130. You're welcome to stop by and see that. I used this equipment to rescue stuff for that system. And by the way, the designer of the system is sitting right over here. So he got into... So let's see. That's how I got into working with the Applesauce, is trying to preserve the software. And I picked up my first system. The Applesauce, this is the first release right here, was created by John Keone Morris, released in June of 2018. He sold them out in the first 16 hours, the first run of them in the first 16 hours. Initially, as I said earlier, it was designed to work with the Apple II. This was created as a device to hook Apple II disk 2 drives to a PC and allow us to be able to copy the copy-protected disks, much easier than we could with any other option at the time. In October of 2021, he added support for PC drives and released an upgrade kit for people that had the older one. That was the Revision 2 box. We added support for all sorts of different file systems, Commodore, Atari, Heathkit, TI. Pretty much any system you can think of right now, we're getting support for those systems into the hardware and the software. Support's ongoing. As I say, we're still adding them. For an example of that, the MTU that I was talking about a moment ago, when I first acquired the system and started working on it, as far as we knew, I was the only person that had software and documentation and a full working system for it. So John helped me get things together to hook my 8-inch drives up to the Applesauce so that I could pull the software off, image the disks. I provided John an image of the disks that I found, and with just that image, he was able to reverse engineer the file system for the disks, for the system, and add support within a couple of days. Support for that had been added into the Applesauce client, and we were then able to verify that all the files were good. We were able to extract files off of the disk onto modern systems so that we could work with them, stuff like that. So more and more systems are being added to Applesauce all the time. It's no longer just an Apple, no longer just PC. All sorts of things are being supported by it. It's been imaging hardware of choice for a lot of museums and educational institutions because it's probably one of the easiest, the client software is one of the easiest to get to work with. It's not command line, it's Windows GUI driven. So it's very simple to pick up and learn, and a lot of hobbyists use it, but it's really used a lot in a lot of museums. Okay, what's different between the Applesauce here and the new Applesauce? The Applesauce Plus in 2023, there were component shortages so that we couldn't make any more of the Applesauces. The main processor and whatnot that was used in them was out of production, and we were unable to build any new ones. So he started in on his Rev 3 design, which is now being called the Applesauce Plus. How does it compare to the original Applesauce? Well, it's currently in production, for one, so you can get one. It has faster processor, more expanded memory. It can support up to 8 drives simultaneously connected at a time. With the old Applesauce, if you wanted to change what drive you were working with, you had to unplug the Applesauce from the computer, take the drive off the back of the Applesauce, plug a new drive in, plug it back into your computer, and start working with it. With this, you've got them all right there. You can leave them all connected. This is a picture of my setup at the house right now. So I just have this basic workstation set up. I don't have to disconnect my drives anymore. I don't have to do anything. Actually, you don't see my 8-inch drive in there, but I have like Apple Disk 2 and a 3.5-inch super drive down there for doing Amiga or Apple or whatever, and a PC disk up there. But now I can just have everything right there in a little workstation, and it's nice and convenient. The Applesauce Plus also upgraded the USB connection. So now it's using high-speed USB as opposed to fast-speed USB. So it's much faster at transferring data back and forth. Let's see. Although the need for it is debatable, and it's been debated a lot in the imaging world, some people felt like the original Applesauce didn't have a high enough imaging resolution to it. So the new one can image, its imaging resolution has been increased. It'll go up to 96 megahertz, and it is user selectable now. So you can, if you decide you want to use a higher resolution than what it thinks, then you can actually set it to something else. Otherwise, you just leave it on its adaptive mode, and it will look at the media that you're imaging and pick whatever it feels is the appropriate resolution to image at. That's also a sign of the commitment that John has for the original Applesauce, in that feature is now part of the original Applesauce system. So he likes to keep those people that bought the original systems supported with new features all the time as well. It doesn't go as high a resolution as the new hardware does, but it is now a new addition to the old system. And also, another thing that is being added with this is a port on the back that allows for connecting an oscilloscope to do simultaneous analog and digital capture of your floppy media. That is a feature that John's been working with some other people on. Client software doesn't have that. The support for it isn't in the client software yet, but it's being added. Let's see. Now, the Applesauce is not the only imaging solution out there. And there are plenty of others, and there are pros and cons about all the different systems. One of the cons for the Applesauce is there are cheaper systems out there, many of which you can DIY yourself if you want. So you can go in, pick up the components, have the board, order a copy of the board, and put it all together yourself if you want to do that. Another thing is that some of those systems will have client software that's not limited to the Mac. Currently, the Applesauce software the client software is limited to a Macintosh. There have been attempts to port that. I've looked at it, trust me, it's a very daunting task at the moment, so we'll see how that goes. There are plenty of options, though, if you don't have a Mac. Many of the Applesauce users will run a virtual machine on a PC or under Linux and run Mac OS on that, and they will use that to connect to the Applesauce. Another option that I think people don't seem to think of very often, that we should all be aware of, is John works really hard to make sure that this will work on the oldest version of Mac OS possible. So there's always the option to pick up an older Mac on the cheap, hopefully, and run it on there. The current oldest version of Mac OS that's supported is 10.13, so that's High Sierra. So theoretically, any Macintosh from late 2009 should run just fine with it. I used to use a 2012 iMac until the hard drive died, and I picked up, when that happened, I just picked up the cheapest entry-level Mac Mini you can find, and it's more than enough to handle it. And that was like $400, I think, to get that. But you can pick up some used Macs, some older ones, fairly cheap these days, so that's an option for running it. Another con for the Applesauce was availability. But with the Applesauce Plus going into production and being shipped now, that's no longer so much of a con against it. Some of the pros for it compared to some of the others. The client software, as I was saying, is very feature rich, and it's very smart. There's a lot of features that I will talk about, I'll point out as we go along, that it does things for you that if you're using one of the other systems, you have to figure out on your own. But it'll figure it out for you and let you, and just, it's very, very feature rich. I mean, going in and editing Flux images, and actually editing the individual fluxes in an image, for example. What else we got here? Easy handling of unknown disks. It's one of the things I was talking about just now. It can handle, if you get a disk, and I run across them all the time in the stuff that I'm working on, there's no label on the disk. There's no indication what system it came from, where it was used. You don't even know if there's any data on it, really. And I know a lot of other people will tell me, when you're using other things, they'll put the disk in, they'll image 2 or 3 tracks, and then they'll dig through that to look and see if they can figure out what the geometry of the disk was or what system it was used on, and then they can figure out what to go and image. Applesauce does that all for you. Within seconds of you popping it in, it will identify the geometry and tell you what the disk is, what system it was used on, and by the time you've read all of that, it's probably finished imaging the disk. So that's a very nice call. Another good pro is that, as we know, disk drives run at a certain speed. The Apple Disk 2 was 300 RPM. The PC high-density 1.2 meg floppies run at 360 RPM. The Atari 810 runs at 288 RPM. So if you're imaging a disk from a system but you're using a drive from a different system that runs at a different speed, that can cause a problem for your image. You might get an image out, but it might not be exactly right. Or where you see it even more often is if you're writing a new disk to use on real hardware, and you're writing, somebody made the image on a system that wasn't the right speed, you're going to write it, you got a problem there too. The Applesauce handles all of that for you. It automatically knows, looks at and sees what's the drive, what's the speed for this drive, what's the media that we're doing, what's the file system. It figures that all out for you and adjusts automatically the RPM. Now, a place where this feature really came in handy is when we added Victor 9000 support to the Applesauce. The Victor 9000, in an attempt to get more data onto the disks, changes the drive speed depending upon where the read-write head is on the disk. So we had to figure out, first off, what the correct speed was for each zone on the disk, which they did. And then John had to set that up using this RPM correction in the system so that now the Applesauce software can read a Victor 9000 disk on non-Victor hardware, create a good image of it. Somebody else can take that image, run it out, create a new disk on non-Victor hardware, and then have that disk actually work on the physical machine just fine. That's something that's really kind of difficult to do on a lot of the other systems that are out there. It also has probably one of the largest number of supported formats that it can import and export out of anything out there. If there's a format and there's a specification for that format, John wants to add it to Applesauce. So we can import Flux images and Flux images from other imaging hardware, sector images. We can export them back out. You can edit them, do all sorts of stuff with them like that. And it's probably got better support for non-PC drives than any other system out there, particularly now that we've got this. This is the XOR, as I was talking about earlier. I'll go into this more in depth here in a few minutes, but this allows us to connect essentially any disk drive you can come up with to the Applesauce. I'll talk about that in a little bit here. Finally, it's just a really solid off-the-shelf solution. So yeah, you can DIY your own hardware if you want, but if you want quick, easy support, solid hardware, and some fantastic software, this is probably your best option.
Very quick question.
Yeah.
The additional support that is added, you keep mentioning the programmer's name. Does he have to compile that support into the software, or is there configuration files?
No, well, actually, both. Okay. Doing file system support, adding support for the new file systems, that's compiled in. Okay. If you want to add support for other disk formats, a lot of that can be done through JSON files. Okay. Like hard disk, hard sector diskettes, things like that are added in through that. Yeah.
Yeah. So if your image has some questionable bits that probably made an error on the original system, can it reconstruct better? A better guess?
Some of it, in some cases, yeah, it would depend on what the issue was with it and whatnot. But I've had several that I've been able to come back, and then with going through the data that came back from it, I've been able to edit the flux in such a way that I've been able to correct errors and problems that were on the disk.
Okay.
Okay, so let's see. So let's look at the Apple Plus hardware. This is the new Apple Plus hardware box, and I have my little beta test unit up here. I have these over at my table if you want to come look at them later. On the front here, we see we have a safe switch. That's like putting a write protect tab on your floppy, but much, much more. When that's turned on, it actually physically disables the write gate from ever becoming active. So it's more than just putting a tab on it. It also, the firmware is designed such that the firmware checks the status of that switch, and if it's on safe, the firmware will not execute any code that could do any destructive action whatsoever. So it gives you extra protection from accidentally damaging any of your data that you're trying to read. We got a bunch of LEDs in the front here. They'll give us the status of what the system's doing at any time. When you first power it on, you'll see they'll all light up in a line and then back down as it does its self-checks. Moving around to the back here, we've got a whole bunch of different connections. We've got a power connector down in the bottom left there. You'll plug in your power supply there. That provides power to the floppy drives. The Applesauce itself draws its power through its USB connection to the host computer. So the power that you're plugging in there is strictly power for the floppy drives themselves. You can plug the Applesauce into a PC or a Mac and open it up as a USB modem and send commands and receive data back from it that way. That protocol that we use is open and documented, and it's being used right now to add support for the Applesauce to the Flux Engine software. Flux Engine at the moment can use an Applesauce on a PC or Linux or Mac and start to do imaging if you want to use the Flux Engine software. We have over here in the bottom right a couple of sync sensor ports. Those are for providing a sync signal if you've got a drive that doesn't use index sensors, such as the Apple Disk 2. Then we have let's see, where we go, various drive connectors. Starting up here on the top left, we've got a 20-pin connector. That's for connecting Apple Disk 2 drives. We've got down below it there a 19-pin connector for some of the later Apple II and 5.25 inch and 5.25 inch and 3.5 inch drives. And then right above it, we have a 34-pin Shugart PC connector for connecting PC drives. That's also where the new XOR connects into the Applesauce. And then we have in the top left there a connector to provide power to the PC drives. Apple drives draw their power through the data cable. So there's an extra connector there to power your PC drives. And then down here on the bottom right, we have the trigger connector. That's where you'll be connecting an oscilloscope if you want to start getting into some of the more advanced digital recovery. All right. Doing all right so far? Mm-hmm. Okay, good.
You said it is Mac. Is it operating on the new Mac silicon?
On the pardon?
Does it operate on the new Mac M1s?
Yes. It works on all Macs going as far back as Mac OS 10.13. So my current system that I use is an M2 Mac Mini. All right. So let's talk about the actual, that's the hardware. Let's talk about the actual software. And I think the software is the real gem in the whole package myself. First thing you do when you use it is you're going to attach your drives to the Applesauce. You're going to plug the Applesauce into your host computer. And the first thing it's going to do is it's going to pop up a drive select window. This lets you select what port, which of the ports you're using, what type of drive you have on it, and configure it, your whole configuration. So this is what I currently have on mine here. You can see I have an Apple Disk 2. I have an Apple 3.5-inch Super Drive. I've got a Teak FD55 and a CumeTrack 842. That's my 8-inch drive. So with the Applesauce Plus, I pick whichever drive I want to work with, select that, and then that's what I'm going to be imaging with. If I want to change to a different one, I just go in here, select a different drive. I don't have to, no longer do I have to disconnect it and plug them back in. I know there's some people here that have Applesauces, and I tell you, it's worth that. That feature alone is awesome.
Is it a single drive at a time? I mean,
You're going to be working with a single drive at a time, yeah.
Like here, you have both the Cume and the Teak.
Yeah, the Teak is drive 1
right
on the cable, and the Cume is drive 2 on the cable.
Yeah.
So if I tell it I'm going to work with that, it's going to be going out down the data cable.
Like you said, you can have up to 8 already set.
You can have up to 8 drives on there. You can choose whichever one you want to work with.
So on the 19 pin, you can daisy chain.
Yeah, exactly. So you could have like 2 3.5-inch drives on there and 2 5.25-inch drives on the 19 pin.
Quick question about that. You mentioned that it's worth it for that feature, John, to unplug them. But supposing you wanted to disconnect one of those 8 drives and connect a new one, how easy is that process?
You have to unplug the Applesauce to power it down from the thing before you go into doing anything on it. It does have, on the back, there's a little LED here that if you go to pull a drive out off the back, that LED's lit. That's to warn you that it's still powered and you want to unplug it first. So if you're going to go to that process, yes, you'll still be powering it down. One of the first things you do, I've got these are all configured. You can have configurations for different drives. So I could say, change my Cume. I want to use a Shugart on there. I'll have that configuration stored there. I can just go in, select down at the bottom the little gear down there and tell it I want to put my Shugart on there instead. So I can have that configuration. But when you're adding a new drive, you'll need to configure it first. This, most of the time, is done automatically for you by the Applesauce. You can just hit probe drive, the Applesauce will go out, figure out what the drive is, fill in all the parameters for that drive. You can give it whatever name you want, whatever you want to call it, and save it out on there. Occasionally, in the past, it was more so with 8-inch drives, but with the new Applesauce Plus, that's becoming less. You'll do a manual setup, in which case you have to know the information and fill it in yourself. That's, like I said, I had to do that with my original Applesauce when I put the 8-inch drives on there because it was unable to probe them and find out what they were. That's changing with the new Applesauce and the new XOR device. But the XOR device at the same time might be supporting a really unique drive. Let's say you've got some of the old 3-inch drives and you want to put it on there. So you might need to come in and fill in the parameters for that. After you've configured your drive and you've selected that you want to work with it, you want to run drive diagnostics. The Applesauce has some very nice diagnostics features in it I use it to just test drives. I'll plug drives into it and run them on and have it test the drive for me to tell me what its state is in, whether it's working or not. This is one of my PC drives here, because I've got 2 heads, reading 0, reading 1, writing 0, and writing 1. So this is one of my PC drives. You will get different tests up here based on the type of drive that you're checking at the time. It goes through, it's checking that it can read and write it, what the power signals are with the drive, whether the index sensor, the write protects, all this stuff is working or not. And if there's not, you'll get a big red X there and it will tell you what you need to take care of in the drive. You can also check the RPM for the drive, and that will run continuously. So if your drive is not running at the right speed, you can sit there and tweak the pot on it to adjust it, and you can watch it right here on the Applesauce as it adjusts. This is for I was testing a high density drive there, so it's showing 360. I can also test low density on that as well for the PCs. Yeah. Oh,
Just back up one. 8-inch drives typically have power as a separate cable. So is that
yeah, that is. Yeah, I'll talk about that a little more here when I get to the applesauce, but that's what I've got this for here, is for that. So when I get to the XOR here, and I'll talk about the power with it. All right, so let's see. After you image, or after you've connected it and tested it, then one of the other factors that plays a big part in how well your images come out is the next test, which is the analog characteristics for the drive. Here we have several different parts. Let's start with noise. Down here in the lower left, when a disk drive is reading and it's having trouble finding data, it'll start to turn up the signal gain. And as that signal gain goes up, if it gets high enough, sometimes that disk drive can hallucinate bits. That's the noise, okay? Most of the time, for most of the stuff that we're doing, it doesn't matter. And a high noise rating is not necessarily a sign of a bad drive. The drive will be perfectly fine. Most cases, it doesn't really matter. There are a few cases that you may run across, such as I have a CompuColor 2 computer, and that disk system was really odd. It needs a very low noise drive to successfully read it. Or if you have, say, copy protected disks that left flux-free areas on the disk where there's no flux at all, then the noise can have an effect because the drive's going to be reading, there's no data there, it's going to crank up the gain, and it might just start generating fictitious bits. So in those cases, you really want a low noise drive, but the majority of the time, it really doesn't make any difference. What does make a difference is the window of stability. This will tell you what you can image on that system and what you can't, and how good the drive's going to be for doing that. Different systems are looking to have their data in different ranges. Commodore 64, 3.25 microseconds to 12 microseconds. Apple is 4 to 12, although you want to go to 16 really for some copy protections. The Victor 9000 is 1.2 to 7.5. So here, what's the important part is to look at that yellow line. Where does it hit peak and how long does it hold it? In my example here, the signal's 100% stable between 2 and 17 microseconds. So that should be good for copying most things. Now this is done low density. You see down at the bottom, I've selected low density. So this is testing the 360K mode of this PC drive, not the high density drive. If I test the high density drive, I'll get a completely different window because the filter is going to be changed based on the media that it's working with. And I get this window for that same drive. This one actually would be a good one for copying Victor disks because it actually covers that full range of the Victor. So that really lets you know if you can copy the disks, you can successfully image the disks that you want to do on that particular drive, or if you need to get another drive. Yeah.
What have you learned about reading floppy disks that are 30 years old? I mean, what happens to them? Can you compensate?
It depends on how well they've been cared for. Most of them I've found, I have my original Apple II disks, and they're just fine. No problems
Do like
whatsoever.
single density survive better than double density? Or?
They all seem to be about the same. Now, if they're not taken care of, they get moldy or dirty or other stuff, then depends.
But if
Some-
it fails, are there things you can tweak?
There are some things you can tweak and things you can do, but there are cases where you might have a disk that you're going to get one read out of it, and that's it. So you want it to be good when you do. There are some brands, I've not run across any myself, but there are some brands that seem to have a reputation for the media just flaking apart, you know. So, yeah, the physical media. Yeah.
What if you have like a stubborn drive that, you know, I've seen it in like hard drives do, where you can read maybe first 4 or 5 sectors, and then that 6th or 7th may be a little flaky, and then you read the others.
I'll cover that here in a minute. After I get from this here, we're about to move into actually imaging some disks, and I'll talk about some of that here.
Okay.
Okay, so let's see, test modes, different. So anyway, this is high density, low density. If you have drives that have multiple modes like that, you really want to test both modes to make sure that your RPMs are right, what your window is, and things like that.
And
So,
here it looks like your noise is double what the other was.
yeah, the noise is higher here, and it's just, yeah, really, in most cases, it's not going to make any difference. It's not going to really matter. Most PC disks, you don't have a lot of no flux areas on the drive. It wasn't really big with the PC like it was with the Apple. Okay. Let's see where I am in my notes here. So, all right. So after we've configured the drive, we've tested it, it's working good, it's going to meet our needs, we want to image some disks. So this is the fast imager for Applesauce. It's fast. Trust me, it is fast. It's a sector-based imager. By that, I mean that it's reading each track and sector and saving the data. So it's basically like a computer like the original computer would have been working with it. It's going to say, give me track 0, sector 0. And Applesauce is going to return that. As it reads each sector, you'll get an indication in the matrix there of whether the sector's good. You'll get a green. If it's bad, you'll get a red square. Within seconds of you popping that disk in and hitting the image disk, you will get a message up there telling you the geometry of the disk. How many tracks is it? How many sectors is it? You'll know instantly, is it FM? Is it MFM? Is it GCR? What's the encoding that was used? And as soon as it finds a known directory structure that matches file systems that it knows of, it'll tell you what are the files on the disk. And if any of them are good, it will verify each individual file for you as well. It figures out all of that for you, just getting started. Once you've done that, down here you'll see all the available file formats, export formats, that you can export that particular type of disk to. I'll show another image here in a minute. And your question about bad sectors. I've got a retry bad button here. It's grayed out right here because I haven't started to do anything. Applesauce, it'll read through the disk. If there are bad sectors, it will save the good sectors, and it will allow you to go back and retry just the bad sectors. Okay, so the best part of it, though, is that you can take and open the drive, take the disk out, clean the disk, put it back in, reposition it, hit the retry bad, and it will just do the bad sectors. And you can do that as many times as you want. We have a clean head button here. So say you've got some bad sectors and you think, well, maybe I need to clean the heads. You can take the disk out, put a cleaning disk in, click that button, it'll run a clean head pattern. You can take it back out, put your disk back in, retry bad, just the bad sectors. Or if you need to open the drive up and clean the head with Q-tip and some IPA, whatever. allows you to just redo those. And as it recovers more sectors, if you have to do it again, it will still do just the bad sectors. So let's see. You can do that as many times as you want. Okay. Let's take, here's a disk that I did. You can see at the top, it's telling me this is an Applesauce 3.2 disk. 14 files were detected, and they all verify as good. Green sectors for all of the sectors, so it read everything fine. It tells me here that it's a GCR encoded disk. It's 13 sectors of 256 bytes per sector per track. So it gave me that the moment I hit the image disk. It started reading that first track and it says, oh, this is what you've got. Down here, it's telling me the different file exports that I can export this particular format to. I can do a WAS, which is a special Apple II format for, particularly for handling copy protected disks. 13 sector, or export the disk contents as files. So I can export all the files that are on this disk individually to my PC and sit there and then go through them separately. If I hit the Show Catalog button up here, it shows me the catalog of the disk that it read. If any of these files had a problem, it would highlight that file and tell me, hey, this is the one that you've got a problem with. Here's an example of one I did. I ended up with a bad sector on it. This was a ProDOS disk, 8 files, one of them's got an error. Well, it probably uses that sector that's highlighted red. In this case, I opened the disk drive, closed it part way, reopened it and closed it again to kind of center the disk in. Back in the early Apple II days, that was kind of a common thing to do if you had a disk errors, and it kind of became a habit with me anytime I put any disk in now, is to just kind of partially close it. After I did that, boom, hit retry bad, the sector was read fine, and I was good.
What about disks that purposely have bad sectors into the copyright protection?
Okay, if you're talking about copy protected things, those you would do on what I'm going to talk about next. Okay? So, let's see, head fire section. You would do something like that more likely on the Flux Imager. The Flux Imager takes and makes a flux image. It makes a representation of the magnetic fluxes on the disk and saves that. So look at my time, I gotta speed up here a little bit. It also, we have space here for metadata to go on with this. So we can fill in all the metadata for it. Publisher, who produced it, a lot of that, if you're an archivist like I am, that's very important information to capture. You want to know the provenance for the disks. This saves in a format that's called, it's a flux format called A2R that was designed for the Applesauce. One misconception is that A2R, people think, well, that's only for Apple II formats, but it's not. It stores any flux format from any type of system or drive or anything. One of the other metadata features he added in is the ability to capture a picture of the disk from your system while you're doing it and have that save with the disk image and everything. So you can keep that as well. So you can do front, back, you want to close in on the label, whatever.
Double plus good.
Yes, seriously, it is. That is something that all of us that were Applesauce users were really happy to see when he got that added in there. So that is very awesome. So, okay. The other thing we have, you can see down here under the clean head, we have the resolution. That's where if you want to use a higher resolution for your imaging, you can set it. Oh, and the camera can be used on the Fast Imager as well. It's not just for the Flux Imager. It can be used on the Fast Imager as well. That's where you can set it. Otherwise, you just normally leave that at adaptive. You can set the number if you're doing a multi-disc set. You can set the number of the disk, which disk number this is, and what it's called. I have this here as an example of a PC game that I was imaging. I've filled in all of the metadata. I was like, this is disk number 2. It was the scenario disk. Disk 1 in this case was the program disk itself. You see an image up here that's a graphical image of the flux on the disk, which in most cases like this, you can see individual sectors around. That's side 0 and side 1. At this point, I can hit save and go on and image another disk if I want, or I can hit save and analyze, and I get to what I think is probably the most advanced feature in the system, and that's the disk analyzer. I could spend an entire panel just going over individual parts of the disk analyzer, and I don't have that much time left, so I'm trying to hurry up here. I will try and give you an idea of some of the things it can do. If you want to talk about it more, you can hit me up at my table here. I'll be happy to tell you as much as I can. I'm still learning about a lot of what this can do. We can see here we've got a nibble stream in the middle here. That's going to be all of your sync bytes, your address markers, all the data for each sector and track are going to be, that's all right in here. We see at the top there's some controls, some information about it. It's an IBM 9x512 format. Down here at the bottom we have what is the tracks, and then we have the same images before. The track images here, they'll be green if they're good, they'll be orange or red if there are issues. If you select on one of those, it'll change what data you're looking at up here. So if you select on track 1, you'll get track 1's data up there. You'll see these are split in 2. That represents head 0 and head 1 for that track. Okay? Then we have, I gotta skip ahead. The sector view. So I went up here in the little drop down, I told it I want to look at physical sectors. Now I'm looking at a standard sector view for the disk image. So I've got the data in hex and ASCII. So I can scan through here if I'm looking for strings or something like that. As usual, pick the track sectors that I want to look at. Going back up there again, now I can select logical blocks and view it that way. Now the logical block is how the operating system sees it. So you've got like CPM, the logical block in CPM can be made up of multiple sectors on the disk. Or if you're in the TRS-80 world, you think granules. This allows me to look at it that way. It also identifies up here whether this block is a OS block, as it is in this case, it's a BIOS parameter block, or it's a block that goes with a particular file. Then we have, and this is the one that saved my butt a few times, this is the Flux editor. The Flux editor is showing me the fluxes that it's read up off of the disk, and I select the track so I can go to different ones that I want to. I had a disk once that Applesauce warned me, it says something's not quite right. Most of the disk was fine, but there was one little area of it that wasn't quite right. With the Flux editor, you can actually go up there, you can move fluxes earlier or later, you can delete a flux, you can add a flux, full-on editing of the actual fluxes of the disk. My disk that I had, adding a flux in the right spot, it was missing a flux when it read. So adding a flux in the right spot got everything to line up, and I had a good read of the disk at that point. That's a really powerful feature. You don't use it very often, but when you do, it's there and it's handy to have. Then we have the flux timing graph. This is, as we were talking about, your fluxes need to be in different ranges depending upon the format that you're doing. You want to see fairly solid lines concentrated in these areas. If you see it's like cloudy, it looks fuzzy or blurry, that's often an indication you need to clean your heads. Okay. Moving down, we can change the view here to a file system view that says FAT12 there on the control. It'll show us what sectors are in use, which ones are not being used. It'll list out the files that are on the disk. If I select one of those files, it will show me the sectors that it's using on the disk at that time. Okay? And I can export individual files out from here. This saved my butt once. You can compare, it's the compare and repair feature. So if you have two images of the same disk, or different disks if you want, you can compare those images. Applesauce will go through and tell you what are the differences between these images. What's the same? Where it's really handy is once, let's see, my notes. Once I was working with my MTU 130 and I imaged the disk. One of the first things I did when I got that system, I wanted to image the disks and save the software so that we didn't lose any of it. I imaged the disk, but a mistake on my part, I only imaged one side of the disk, and it was a double-sided disk. When we discovered the error, I went back to go redo the disk, and I discovered that at some point the disk had suffered some damage. So I couldn't get a full image of the whole thing. I was able to take the original first image I had that had a good side 0 and the new image that was partially damaged and take the good parts of side 0 and paste them in using this tool into the new disk image, and I was able to rescue the majority of it. I went from, what did I have? I went from 68 damaged files on that disk to 15 damaged files. And I'm still working on those. I think I'm going to be able to get them all back here. So that is a tool that's really handy and useful to have as well. A2R is, as I said, is primarily an archiving format. You don't use it in like emulators or something. For that, you need to export it out to another format. And again, when you go to export, it will tell you what are the compatible image formats that you can export this media to. Yeah.
All right, in its conversion to those formats, have you been able to assess how much of the information might be lost?
It depends on what format you're doing. Some formats will store more information than others. I think it's, is it IMD? One of the two, IMD, I always forget IMD or IMG. One of them doesn't store the geometry, for example. So you're going to lose that information if you export to it. But you can pick some others or whatnot. I want to get through here real quick. If you want to use a disk on physical hardware, A2R, as I said, is primarily an archiving format. You can write that, but you have to go through, Applesauce has a mastering process that you go through. Most cases, it will automatically generate markers for you, but there are times when you have to do them yourself. Another option is you export to one of the other formats, and then you can use the disk writer here. This will allow you to load one of those images and write it out as a new disk to use on physical hardware. We have load image, we've got wipe disk. It will wipe disks for you. Clean head, so if you want to do a clean. It also has a format option, but it only supports formatting a new blank disk for Apple or MS-DOS. This is mostly useful, since you can write a new disk to it. This is mostly useful because quite often when you're probing your disks or you're testing them, Applesauce will want a formatted disk in one of these two formats. So you can pop over here, run one off real quick, and then run your drive tests on it. This is the Expandama. This I want to get to because this is really exciting. This is a new addition. This works with both the old Applesauce, as long as you've got one of the Rev 2s that have been upgraded to use a PC drive, or the new one. This was originally designed as a solution for connecting 8-inch drives to the Applesauce. It provides 50 pin to 34 pin conversion. It also provides power. A lot of 8-inch drives use AC power for the spindle, and they'll use DC power for running the drives. It provides both, and that's what my little cable here is. This is a special cable that I've made for my drives, plugs into the system here, and it provides me with DC power for the drive and AC power for the spindles, both in one. Most other solutions that I found, you're going to get a box that does the conversion, then you're going to have separate AC and separate DC power supplies for it. But as he was working on this, he realized this could become so much more. You'll note there's like a PCI slot on it. We have these modules. This right here can remap any of the inputs, any of the lines on here to any other line. So if you've got a drive that's got a configuration that you want to attach to it, but it doesn't match this, say, a standard PC format, you can get a module and make it, plug that in, and now those lines will be mapped so you can connect that drive and use it on the system. The power connector here provides you with 5 volt, 12 volt, and 24 volts. So you can build a cable to work with whatever you need. If you've got something that uses a different voltage, this module actually supports putting a power regulator on it and remapping the power to the lines if you need to send them out through that. So this tool is going to be very useful for getting a lot of obscure and unique drives connected to the system and get them imaging.
So that replaces the applesauce.
No, this does not replace the applesauce. This is used in addition to the applesauce.
Okay.
So I plug in, like with mine, I plug my 8-inch drives in here, plug the power connection into them. This connector plugs into the applesauce. Okay. There are a whole bunch of other features about applesauce. I don't have a whole lot of time left. There's a bulk processor that lets you convert images, extract catalogs. There's a metadata inspector to go back and look at that. CPM definitions, if you've got CPM disks, you know there's a lot of different variations in those. You want to extract the files off. Applesauce knows a bunch of them. There's an editor so that if you have something that it doesn't know, you can easily add it in and add it to the database. Pull off forth blocks if you work with forth programs, which I did in the past. If you're working with MAME, you can generate software entries from it. And the disk format, JSON, is where you add like hard sector formats to it, or variations on, say, PC formats, things like that. So finally, if you want, there's our website. We have a Wikipedia available that's not just about the applesauce, but about disk drives in general and imaging. There's the Discord, Applesauce Discord. There's a lot of people in there that are very knowledgeable. We're more than happy to help. If you've got unique systems, we love to hear about them, different drive types. We like to get support added in. And of course, you can support John and the whole project on Patreon. You can order systems on the website. Yeah.
Is any of this open source?
The software is not open source at the moment. Okay, there are some of us that have access to it, particularly in case something happens to John.
That's one of the reasons I was asking.
That has been taken into account. All of everything for the hardware, everything needed to do new hardware, all of the plans for it, all of the software. There are other people that have access to that will be able to take care of it if that. Right now, John does the primary programming.
Is he healthy?
Oh yeah, he's very healthy and
exercising every day.
He's pretty amazing. He has amazed me with his knowledge of disk imaging. Yes.
Why applesauce? The name.
Why?
Yeah.
It's kind of a pun on the fact that he originally did this for the Apple II.
Okay.
And that's why when he started on revision 3 and he was talking about what do I call it, he's saying I'm Rev 3, we came up with Applesauce Plus because your Apple II, the Apple II Plus was the next one. So That's kind of the play on there. And he loves funky names and puns, so that's why it's the Expandorama or the XOR. So, all right, I want to thank you all for coming. I hope you enjoyed it.